Hello, ladies and gentlemen. Root Beer here, and I'm going to be looking at another Alberta high school math contest. This time it'll be part 2 of the paper from the 2010-2011 school year. So remember, part 1 is the multiple choice contest. It's written in November of the school year, and then in February we have the part 2 of the paper. So there's 5 questions here, as is standard. 1, 2, 3, 4, 5. They tend to increase in difficulty. If you'd like a copy of this contest, I would, of course, encourage you to click the very first link down in the description. You can get a little copy for yourself to work through the problems. We're just going to do problem number 1 in this video. A cross-shaped figure is made up of 5 unit squares. Determine which has the larger area. The circle, touching all 8 outside corners of this figure, as shown in the diagram, or the square touching the same 8 corners. So they've put a little square around it. Okay, well, we need to know which has the larger area. Fine. How are we going to find these areas? Let's focus on the circle. That's a terrible circle. How about I draw the cross first? I don't know. My drawing skills obviously not good today. I will try the circle again. Nope. There, I used a nearby mug. Okay. And even that didn't clearly work out exactly the way I wanted it to. Okay, let's try and put a cross in here. Okay, there we go. We'll pretend that those are nice unit squares. Okay, how do you find the area of a circle? Well, the area of a circle is pi r squared. So we need to know the radius. How can we possibly find the radius? Well, one thing to note, and you could say, you should be justifying this because this is a full solution contest. So we'll say, by symmetry, the center of the cross is the center of the circle. What we're going to do is we're going to draw a line through the center to sort of opposite sides, and this blue line is going to be a nice little diameter. And so again, you don't really have to be super exact when you say these things. You can just say by symmetry. I would say it's clear this is going to be a diameter, but because it's a full written contest, we do need to justify a little bit. So by symmetry, we can draw a diameter. And remember, diameters are twice the radius. But I can actually figure out this diameter's length and then divide by 2 and get the radius. Right? How are we going to do that? Well, they're unit squares. Okay, and squares have nice little right angles there. So we've got this blue line is the diagonal of a 1/3 rectangle. So the diameter by Pythagoras is the square of the diameter is going to be 3 squared plus 1 squared, which is 10. So the diameter is going to be root 10. Okay. And so the radius is going to be half of that. Which, there's lots of ways you could try and write this out. You could split the root 10 into root 5, root 2. And then say, well, 2 is just root 2, and cancel some things out. You could say it's root 5 halves. Or you could leave it as root 10 over 2 if you prefer to have your denominator rationalized. There's no exact way to have to do this. And so now we can get the area of the circle. Okay? So that's going to be pi r squared. So that's pi. And then 5 halves squared. So that's going to be 5 pi by 2. Okay, there's our answer for the area of the circle. We need to find if this is bigger than the area of the square, so now let's focus on that square. Now, I think the question should be slightly better worded, because there's lots of ways to make, I think, a square. Well, actually, no. I was going to say there should be lots of ways to make a square that hits all 8 points, but no, I think because these two are at the same level, any line between them is going to... Yeah, no. No, they wrote a good question. I'm just being silly. So I have a bunch of little right angles here. And since these are both 1, we can see, this is going to be 45, 90 degree here, so we'll get 45, 90, and 45. So we get a lot of 45 degrees and 90 degrees and things like that. Okay, we can draw that on our picture. How do you find the area of a square? Well, you need the side length, and you just square it. That's literally where the term of raising to the power 2 and calling it squaring comes from. So how can I find S? Well, we'll use a different color. Let's use pink. We don't use pink or orange. I hardly ever use orange. Okay. What we can do is we can drop this nice little orange line here. We should at least briefly justify why this is going to be S, but you can work with some angles. So you can say this is 45 degrees. 45 degrees and 45 degrees, and so you're going to get nice little sort of rectangle, and so it'll have to be the same as the side length. You can very briefly justify that if you want to. I think just labeling the angles here, and especially the right angle that we get down here, is probably good enough. Okay, so the blue, or sorry, not the blue line, the orange line now is S. And what is it? Well, we can see, thanks to those 45 degrees, that it's going to be 2 of the diagonal of these little squares. So the Pythagorean theorem comes in once again, and this is going to be the square root of 1 squared plus 1 squared, or it's going to be root 2. And so we have 2 root 2's. So the side length of our square, the square that encloses the little cross, is going to be 2 root 2. So now the area, so the area of the circle was 5 pi over 2. The area of the square is 2 root 2 all squared, better known as 8. Okay, which of these is bigger? And remember, we can't use a calculator, so you can't just say, okay, 5 pi and blah, 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 blah. Okay? But we can say something like, well, I know for a fact pi is more than 3.1 and pi is less than 3.2, right? So if I multiply by 5, I'll get 15.5 is less than 5 pi is less than 16, right? And then you divide by 2, and you'll get 7.75 is less than the area of the circle is less than 8. And so the reason I didn't quite know which one was going to be bigger, but I just gave very, very loose bounds on pi. Hey, pi is 3.1415926. You don't need all of that. We just rounded it off. Maybe I should have gone to 2 decimal places if it wasn't really clear, but it didn't take too long to work it out. We can see, aha, there we go. So the square is bigger, or has more area. Okay, and we know exactly what its area is. It's 8. And it looks like we've got everything working out for us. So that's question number 1. As I said at the start, if you want a copy, click the very first link in the description, download it, try problem 2 before we get there, 3, 4, even 5. I'll see you in the next video for problem number 2.